Okay, hi everyone. Today what I'm going to try and demonstrate is that friction as a force is an inequality. So it's one of the more difficult forces to sort of master in the M1 course. Usually we can just calculate it and put it into an equation. So I'm going to try and demonstrate it today. But to make Mr. McMahon happy, I've got to draw my free body diagram first. And obviously this is a particle. So I'm drawing first my weight, okay, which is going to be the mass of the object times g. And then, because we've got a slope, I'm going to have to draw my resolved forces triangle. I've got one force that is parallel to the slope, and the other perpendicular. And I know because this is the resultant force, that the forces have to be head to tail. Okay? So this force here, if I call this theta, this side of the triangle is going to be mg cosine of theta. And then this side is going to be mg sine of theta. The other forces are, we have a contact force, because this component isn't forcing the mass through the table, so it must be balanced. And then, well, if this force is the only one that's acting parallel to the slope and my mass is in equilibrium, then there must be some force stopping it from sliding down the slope. And I think from experience we know that that is our frictional force. Okay? However, I can apply another force to this object with my Newton meter, and I can show you that because the mass, g, and the angle are constant, this force must be constant, whatever force I apply parallel going up the slope. So, here's my Newton meter, and I'm applying a force to this, and the bag is still in equilibrium, which means to balance mg sine theta, the frictional force must have decreased by, you can probably just see it, by 2.5 newtons. Okay? So, I hope that helps you visualise this idea that friction being an inequality.